Welcome to Commander Group of Schools online classes. Yesterday we had seen the real numbers in that rational numbers. So now today once again we'll recall about rational numbers. Rational numbers are those numbers which can be expressed in the form of P by Q, where P and Q are integers and Q is not equal to 0. In another form, rational numbers are nothing but terminating decimals, non-terminating recurring decimals. Terminating decimals and non-terminating recurring decimals. Terminating decimals, you know. So here 0.42. So here if you observe, after the decimal point we have finite number of digits. So here we have 2 digits, so we can say that it is a terminating decimal. Whereas non-terminating recurring decimal means 0.2/3. So it is a non-terminating. It's a non-terminating means it doesn't end here. So the digit is repeating, one digit is repeating. So we can say that non-terminating recurring decimal. So now here in non-terminating recurring decimal also we have 2 types. One is pure recurring decimal, mixed recurring decimal. So here, what is pure recurring decimal? If you observe here 0.234 bar 234. It's a pure recurring decimal. Why it is called as pure recurring decimal? After the point, all the digits which are in the right side, they are repeating. All the digits, I am repeating again, all the digits after the decimal point are repeating. So we call it as pure recurring decimal. And here if you observe 0.6/5, it's a mixed recurring decimal. Why? Because after the decimal point on the right side we can see one digit is not having the recurring part, it is not in recurring part, and another is in recurring part. So the decimals which is having recurring part and non-recurring part, we call it as mixed recurring decimal. We call it as a mixed recurring decimal. Now we will see the conversion of terminating decimal or non-terminating recurring decimal in the form of P by Q. Already you have learned about 0.36. It's a terminating decimal. You have learned the conversion in the form of P by Q in 8th class itself. But once again we will recall. So 0.36. So after the decimal point we have 2 digits. So you multiply with 100. When you are multiplying with 100, then you have to divide also. So whatever the operation you do, that is, if you add means you have to subtract, if you multiply you have to divide. So here 0.36, after the decimal point we have 2 digits, so you multiply with 100 and divide with 100. So into 100 by 100. So now 0.36 into 100, 36 by 100. While representing in the form of P by Q, you should represent in simplified form. So how to represent in simplified form? Here we will divide with 4 or 2. Just we start with 2. 2 1s are 2 8s are 2 5s are 0. So here 2 9s are 2 25. So now here again once again we can see that here it is in its lowest terms or not, once we have to check. So 9 still we can't express in lowest term, or 25 cannot be expressed in lowest terms. So 9 by 25. So 0.36 in the form of P by Q is 9 by 25. So this is a terminating decimal. Terminating decimal in P by Q form we can express it very easily. So now we will come back to the pure recurring decimal. So what is pure recurring decimal? The number of digits after the decimal point are completely not having any recurring part. So all the digits are having recurring part. So for example 0.42. 0.42. Here after the decimal point the digits are in recurring part. Completely they are in recurring part. We call it as pure recurring decimal. This we are going to convert in the form of P by Q. This you know already, you learned it. So let us assume it as X. And here we have to see the period and periodicity. So what is the period? Period is here too, and periodicity. So here let us multiply with how many digits in recurring part here? 2 digits. So multiply with 10 square, that is 100 on both sides. So why we have to take the powers of 10 only here? Why? Because it is a decimal. Decimal means what? 10th part. So 1/10th part. So here 10 square we are taking, that is with 100. So why? Because we are having the digits in recurring part. 2 digits are there. So we are multiplying with 100. So now 100 into X is equal to 100 into 0.4242 and so on. So 4242 and so on. If you multiply with 100, 100x, 100 into, so 42.4242. So let us take it as equation 2. This we will assume it as equation 1. Let us subtract this both. So 100x is equal to 42.4242, and the first equation is x is equal to 0.4242 and so on. By subtracting this both, 100 minus 1 how much? 99x is equal to, so this part completely cancels. 42 minus 0, 42. So now here what you got? 99x is equal to 42. So x is equal to 42 by 99. Can we write it in simplest form? We have to see. So here if you observe, with 2 doesn't goes denominator. With 3 does it goes or not? We have to check. 3 ones are and 3 fours are. Here 3 threes are, 3 threes are. Then this we can't simplify it. So 14 by 33. So the P by Q form of 0.42 is nothing but 14 by 33. This you had learned this method in 8th class also. So now the thing is for mixed recurring decimal. For mixed recurring decimal. For example, let us take 0.2 bar 3. So it's a mixed recurring decimal. Why it is mixed recurring decimal? After the decimal point we have one non-recurring part and one recurring part. One digit at least should not be repeated and remaining can be repeated. That is known as mixed recurring decimal. So let us take this as x. Let us assume this as x. Now we are going to convert this in the form of P by Q. How to convert this in the form of P by Q? For that, you see after the decimal point, how many digits are there? Only one digit is there for non-recurring part. So let us multiply with 10 on both sides. So if you multiply with 10, 10 into x, 10 into 0.2 bar 3. So why we are multiplying only with 10? Because here after the decimal point we have only one digit which is not repeating. In order to make that right side only the recurring part left over, for that sake we are multiplying with 10. So 10 into x, 10x, and if you multiply with 10, what happens? 2 point bar 3 we will get. So 10x is equal to 2 point bar 3, that equal to 2 plus 0 point bar 3. So now you know the value of 0 point bar 3. So it is nothing but 2 plus 3 by 9. So now here 10x is equal to, so 9 LCM, 2 means 2 by 1 and 9 2s are 18 plus 9 1s are 9. So 1 into 3, 3. So 10x is equal to 18 plus 3, 21 by 9. X is equal to 21 by 9 into 10. So x is equal to 21 by 90. We can simplify. So how to simplify? 3 7s are 3 30s are. Than this we can't simplify. So 7 by 30. So simplified form of mixed recurring decimal, in easier way we can do it. What is that? As I told you, after the decimal point, if how many digits are there, we have to see how many digits are in recurring part and how many digits are in non-recurring part. First we have to see how many digits are in non-recurring part. To that you have to. So if it is 1 digit, we will multiply with 10. If it is 2 digits, we will multiply with 100. If 3 digits, with 1000. So now here only 1 digit is in non-recurring part. So I am multiplying with 10. So 10 into x is equal 10 into 0.2 bar 3. So with 10 we multiply 2 bar 3. So I had separated that is 2 plus 0 bar 3 and 2 plus what is 0 bar 3? It is nothing but 3 by 9. So I took 9 as LCM. 9 2s are 18 plus 3. 18 plus 3 is nothing but 21 by 9. So 10 is this side. If you send the other side, it divides. So 21 by 9 into 10, 90. 21 by 90 by simplifying, we got 7 by 30. So in P by Q form, we had expressed this mixed recurring decimal. So today we have learned how to convert the rational number and irrational number and rational number, terminating decimal, non-terminating recurring decimal. In non-terminating recurring decimal, we had seen the pure recurring decimal and mixed recurring decimal in the form of P by Q. Now we go to the other form. So other method. What is that? Without actually dividing, find which of the following are terminating decimals. So, without actually dividing. So, without actually dividing, how we are going to convert this, how we are going to say that they are terminating decimals. So, here, without actually dividing. So, normally what we will be doing? We will be dividing with 25 and we will be saying that it is a terminating decimal or not. But here without doing any division, how can we do that? For that, let us simplify the denominator. Let us write it as product of prime factors. So 25, we know that 25 can be written as 5 into 5. So that is 3 by 5 square. 3 by 5 square. So, and here for this example also we will see. What is that? 11 by 2 into 9. 9 means we can write it as 3 square. So here if you observe, in the denominator we have 5 square and here in this denominator we have 2 into 3 square. And simply we can say that 3 by 25 it is a terminating decimal. Why? We will see normal division. 25, 3. So 3 doesn't go, so we will place a decimal point, we will take a decimal point. So 0, 25 ones are 25, 30 minus 25, 5. 0 will take again, 25 twos are 50. So now here we got 0.12. It is nothing but a terminating decimal. So now here if you observe, the denominator is having 5 square. And here if you observe, the denominator is having 2 into 3 square. It is not at all a terminating decimal. Without doing also we can say. Why? Because here, for example, if you take 1 by 4. 1 by 4 is nothing but 1 by 2 square. We know that 1 by 4 is nothing but, what is 1 by 4? 1 by 4 is 0.25. 1 by 4 is nothing but 0.25. 0.25 is a terminating decimal. From these examples, what we can arrive? We can arrive that if you want to say without actual dividing, how can we say that it is a terminating decimal means? we have to see the denominator. If the denominator has the powers of 5 and 2, then we can say that it is a terminating decimal. Powers of 2 and powers of 5 not enough. Powers of 5 also we have to take into consideration. So powers of 2, 5 and product of 2 and 5, then we can say that it is a terminating decimal. So now here, once we will recall what is that. So yesterday we had seen the numbers which are rational numbers. Which are rational numbers? Natural numbers, whole numbers, integers are rational numbers. Square root of a number is a whole number, then it is a rational number. Terminating decimal or non-terminating recurring decimal, then they are rational numbers. So now once we will see here, they asked a number which is rational but not an integer. A number which is rational but not an integer. So a number which is rational but not an integer. For that, what we can take an example. So we can take it as 1 by 2 or not. So 1 by 2 I will take it as rational number but not an integer I can say. Why? Because here 1 is a rational number, 1 is an integer, 2 is an integer, but 1 by 2 is not an integer. It is a rational number. And a whole number which is not a natural number. A whole number, but it is not a natural number. You know that it is nothing but 0. Now, an integer which is not a whole number. So now, an integer which is not a whole number. An integer which is not a whole number. Whole number starts from what? 0 onwards. 0, 1, 2, 3 and integer means what? Integer will be having both positive and also negative integers. So here we can say all negative integers. All negative integers are said to be all negative integers we can take for this as the example. So today we had learned more about rational numbers in detail, how to express in the form of P by Q, that is the terminating and non-terminating recurring decimal, and we had seen the method how to find without dividing, without actual division, how can we say that it is a terminating decimal. Thank you.